Chapter 10, Section 3, Performance Metrics of Regression Models. In this section, I will explain how to evaluate prediction performance of a regression model. There are various metrics that can be used to evaluate prediction performance of a regression model. In this lecture, let me focus on these four popular metrics. MAE is an abbreviation of mean absolute error. MAE is the average absolute error between actual and predicted values. It can be expressed by this formula. The underlined part represents computing the average. Let's see it graphically. For simplicity, let's consider a case of simple regression. Here, we have a scatter plot consisting of two variables, x and y. Here, x is the predictor and y is the outcome. We have two observations depicted as blue dots. And we get a regression line depicted by a green straight line. Let's look at the left blue dot. Its x value is x1 and y value is y1. Their actual value, also called observed value. The predicted y value for this observation is y hat 1. It is on the regression line. As we can see, the predicted y value deviates from the actual y value. The deviation is the difference between y hat 1 and y1. It is called error. The error can be positive or negative, depending on which of the predicted value and the actual value is larger or smaller. So, to express the magnitude of error, we can use the absolute value of the error, called absolute error. We can compute absolute errors for other observation. The smaller the absolute error is, the more accurate the prediction is. So, we can evaluate the prediction performance of a regression model by computing the average of these absolute errors. This is mean absolute errors. The lower the MAE is, the better the prediction performance is. Next, let's see MSE and RMSE. MSE is an abbreviation of mean squared error. It is the average of squared errors between actual and predicted values. While MAE is the average of absolute errors, MSE is the average of squared error. Using squared errors, MSE penalizes widely deviated observations largely. So, if the data contains many outliers in the outcome variables, and if we want to avoid the prediction being affected by those outliers, MSE is the better option than MAE. A weakness of MSE is that it is a squared value, and thus it is hard to interpret. So, we can use the squared error of MSE. It is called root mean squared error, RMSE for short. It is also a popularly used metric of a regression model performance. To fully understand how to evaluate a prediction model using these performance metrics, let's recap the concepts of generalizability and overfitting. The purpose of predictive analytics is to build a model that can predict new data accurately. So, in predictive analytics, the prediction model should have high generalizability. That is, a prediction model needs to achieve high prediction performance not only for existing data, but also for newly unseen data. So, even if the prediction model performs well for existing data, it is useless if it performs poorly for new data. On the other hand, even if the model performs a little poorly for existing data, It is useful if it performs well for new data. Overfitting is a phenomenon where a prediction model makes accurate prediction for a particular dataset, but poorly works for additional data. In other words, overfitting refers to a modeling error where a prediction model fits too closely to a particular dataset, and thus poorly fit other unknown datasets. In other words, overfitted model is low in generalizability. After the model training and prediction, we need to evaluate the prediction performance of the regression model. When we use holdout method for model training, we make prediction for both training and test datasets. Then, we can evaluate the model's prediction performance using the prediction results for training and test datasets. Let's consider a case where we evaluate a regression model by MAE. The smaller the MAE is, the better the model is. Here, we have two regression models. Which is the better one? Model 1 performs very well for the training data, but poor for the test data. So, Model 1 seems to overfit the training data. Compared to Model 1, Model 2 performs much worse for the training data, but slightly better for the test data. In such a case, we should choose Model 2 as the better model. As a prediction model, Model 2 is better than Model 1 because Model 2 performs better in the test set. Model 2 performs worse than Model 1 for the training set, but the purpose of a prediction model is not performing well for the training set. A prediction model should have high generalizability, so we should adopt a model that performs better for the test dataset. Model 1 performs very well for the training set, but very poorly for the test set, suggesting that it is overfitted to the training set. In this video, we have seen what MAE, MSE, and RMSE are. These three metrics are popularly used in evaluating performance of a regression model in predictive analytics. Another metric, R-squared, is popularly used in regression analysis as diagnostic analytics. But it is also used in performance evaluation of a regression model in predictive analytics. Let's focus on R-squared in the next video. Thank you for watching. Please thumbs up and subscribe to my channel.